Well, here is actually a survey summary which Mendeley was done by Mendeley. This Netflix analysis was done by me, and so I apologize to Netflix if I messed up. I did actually read tutorials about Netflix on the web, and what is the purpose of Netflix? Well, if you're a user of Netflix, the purpose of Netflix is to deliver you your favorite movie. If you're Netflix, your purpose is to make the most money satisfying your users' needs. And so, actually, this particular use case points out that the actual objective function for a commercial provider of a cloud service is a little complicated because it is not just user satisfaction. Making one user satisfied is when you may be able to make your one user incredibly happy, but what you need to do is to make lots of users happy, and that may not be quite the same problem. And so you need to, for each user, you're in fact that user is probably a household with multiple points of view and interests, and you need to maximize the consumption of movies by that household, and also make certain those movies were good movies so that that household wants to keep their Netflix subscription. So you need to choose the right videos to present to them as possible things to stream down. We have, of course, the need to do what things that YouTube does, store movies in the cloud, download it, have metadata attached to them. The users have profiles which are used for doing this matching, and the users are very critical data is the ranking of movies by users. That's what's used in the probably the most powerful collaborative filtering algorithms. Um, Netflix, like a lot of these companies, is a very complex, sophisticated analysis system. If you read the literature, you will find elegant, simple discussion of systems, but that's not what these people do. They use something very complicated because they've actually able to do that, and that's what they need to do to make the best possible service. And these algorithms they use are continuously changing, and they're able to. When Netflix has enough customers, they can afford to use a subset of them, a small subset, to test a new idea. And so actually that may lead to an improved performance or actually maybe a poorer performance for that subset. So no algorithms are deployed broadly without being tested first on a subset of the audience. And the current approach is, as I essentially built around recommender systems and the streaming video. And those recommender systems are always personalized. They use all sorts of sophisticated technologies, clustering, LDA, latent Dirichlet allocation, elastic nets, just ordinary regression, and all these fancy machine language things, gradient boosted statistics, gradient boosted decision trees. Um, there was a well-known competition which Netflix held to improve its ratings by the accuracy of the ratings by 10%. And the winner of that actually combined 100 different algorithms for the final answer. They use a SQL, traditional databases, NoSQL. They use MapReduce, and all their stuff is hosted on Amazon Web Services. And as I say, the Netflix is typical in some ways or aspects of Amazon. It's e-commerce part of Amazon. The streaming video is common with things like iTunes, Google Play, Pandora, YouTube, Last.fm, etc. This is a really competitive business, cutthroat. Netflix has to stay ahead, and they have to track what other people do and what the trends are, and they have to look at new business initiatives such as building their own, sponsoring their own movies and things like that. So a really exciting, aggressive field. And the parallelism is now over movie, which, if you like, is similar to books and documents and web pages, but somewhat larger size. But the actual processing and analysis is similar, and we've already seen possibly the most important computational type in the collaborative filtering. Here we have web search, another very familiar one. And again, I'm afraid to say this was not given to you by Google, Yahoo, or Microsoft. was given to you by me, based again on study of the internet. In fact, this comes from the Netflix and web search use cases, come from the analysis I did when I cover these applications and later on in this class. So for web search, they have to return quickly enough. I don't know what it is. It used to be a tenth of a second. And a typical search only has 3 words. And you need to make certain that in the first few, and there's something called position at 10, which is how many great responses to your search are there in the first 10 ranked results. And you need to optimize that. So if you look at what's involved in web search, it's very complicated and very difficult for new people to get into this field. You have to crawl the web to grab all this data. You have to pre-process the data to get searchable things, namely the words and positions from whatever you grab from the web. You have to form a so-called inverted index mapping the words to the documents. And when somebody comes along with a query, which is word-based, you know what documents are relevant. When you look at their query, you have to find out the documents using that inverted index, rank the relevance of the document. Here, the famous initial technique used was called PageRank from the founder of Google. But I'm sure that there are many, many methods now used, and a lot of these you will not ever hear about because they're so sensitive for the proprietary dominance or catching upness of the search world, where Google, Yahoo, and Microsoft are fighting, and Baidu, etc., are fighting it out for being number one. So there's a lot of important technologies for advertising. I mean, I remember when I was around when the web, before the web started, and I remember it starting, and people were always very skeptical as to how on earth anybody can make money from the web. And then somebody, I'm not certain who really did this first, realized that advertising, just as in TV, with the TV and radio had that question, initially with radio, certainly in England, where I come from, the government financed the radio as its initial business model. But then at least in the US, public radio has that feature, government and donations and things like that. However, the dominant source of media, funding for media, is advertising. And then somebody had some great idea that advertising could be the model which would actually support search. And there's a huge amount of sophisticated technology to make certain exactly the right ad is put in exactly the right place, and that also that when you get results, should you get real results, and there's not, because there's lots of companies and people who will tell you how to engineer your web page to make it appear properly and within Google, and then so we not only have technology to improve our ranking, we also have technology to make certain the technology to improve our ranking doesn't work. We had Google News as an example of a page which clusters documents into topics. That's where latent and visual allocation and related technologies come in. Here we have the importance of streaming because we have to update the results efficiently. And clouds and MapReduce were probably originally first mainly produced for this particular problem. Here we notice the total size of the problem, which we actually put in an introduction to this course, 45 billion web pages total. At least that's the current estimate. This field is incredibly competitive. Mobile clients are growing very rapidly, but still they don't actually have the monetization, or whatever the word is, done quite right. Namely, there's not enough advertising on mobile clients, and so people need to work on search on mobile and how to get the mobile clients to display ads and get lots of money for those people. Another important issue is the deep web. That is the web that lies behind user interfaces to databases. where obviously the search is not so clear. And another important area of search is image search and video search, because there's more and more video and images uploaded. I mentioned in the introduction there are 500 million photos at the moment being uploaded every day, and 100 hours of video uploaded to YouTube every minute. So it's a big, big world out there. And actually, this doesn't have any striking new techniques. We've already introduced them, although it should be, as I pointed out, this field actually initiated several critical of these techniques. Parallelism is over web pages, and also the parallelism is also over the users issuing the actual independent search requests.